Idea students. So let us see this question that came in JEE Advanced Paper 2 Physics in the year 2022. This question was again a single digit integer correct question. That means the answer to this question will be a single digit integer. If you get this right, you get +3. If you get this wrong, you get -1. This was a fairly easy question. Almost like many students, many sincere students who have prepared diligently would have done this question in the exam. Okay, so uh, well, let's see what is being given in this question. The value of resistance R1 is to be found out, and value of R2 has been given to be 1 ohm. The galvanometer shows null deflection. This is a wire. So basically, this is a meter bridge type of question wherein the wire has a changing cross section area. That means the cross section area is not constant. So using the concept of meter bridge, we have to find the value of R1. Basically, actually, in this question, the radius is varying from 0.2 mm, which is at A, the cross-sectional radius I'm talking about. So this radius is 0.2 mm at the end A and becomes 1 mm at the end B. Okay. So if you write the radius as a function of x, where x is this distance at any from the end A, so radius can be written as initial radius is 0.2 mm plus the change in the radius when we travel the distance L. L is 1 meters given in the question because the center is 0.5 meters. So basically you get a difference of 0.8 mm over the length of 1 meters. So that will be 0.8 divided by 1 into x. So this will be the radius. So now this is the radius as a function of x. You could have also written this using straight line variation. That means you could have assumed r equals to m times x plus m1 times x plus c1. How do you assume the straight line function y equals to mx plus c? So similarly you could have assumed radius as mx plus mx plus c, and then you could have found the value of m and c by putting x equals to 0. At x equals to 0 the radius was 0.2 mm, and at x equals to 1 meters the radius is 1 mm. So anyway you're going to get this radius. Now if I go at distance x and take element dx. So if you take this element dx, अगर हम यहाँ पे एक dx element ले लें, so what is the resistance of this small element dx? So we can say that dr is the resistance of this small element dx. That will be is equals to resistivity rho into length of this is dx. We can divide by cross sectional area. Cross sectional area will be pi r square. So pi into r square. R means 0.2 plus 0.8x ka whole square. Okay. So if you integrate this, let us say let's find out the resistance from. So basically, let's call this point to be j. So on integrating, you can find the resistance from a to j and from j to b. Okay. So we can say that Raj, for Raj, we need to integrate this from 0 to zero point 0.5. 0 to 0.5 rho dx upon pi into 0.2 plus 0.8, 0.2 plus 0.8 x ka whole square, right? And so if you take this rho by pi anyway is going to get cancelled out. So this is going to become rho by pi. Let's write dx upon 0.2 plus 0.8 x का whole square क्या बन जाएगा? So ये आ जाएगा 0.2 plus 0.8 x की पावर एंड 0.8 से डिवाइड भी हो जाएगा. 0.8 से it will get divided, -1 भी आएगी, and you're going to put 0 and 0.5 over here. So what are we going to get here? So this will become minus rho upon 0.8 pi, and if you put x as 0.5, so this will become 0.4. 0.4 plus 0.2 is becomes 0.6 minus 1 by 0.2, right? So this is the resistance of Raj. For I'll calculate the resistance of RJB this side. So RJB will be is equals to 0 से, not 0 से, 0 से नहीं, 0.5 से, 0.5 से 1, and it will be again same function rho dx upon pi into 0.2 plus 0.8 x का होल स्क्वायर. इंटीग्रेशन विल बी सेम, सो यू कैन जस्ट पुट द लिमिट्स हियर. ठीक है, इसमें बस लिमिट्स चेंज हो जाएगी, तो माइनस रो बाई 0.8 पाई. ठीक है, तो यहाँ पे इफ यू पुट एक्स की जगह 1, तो यू आर गोइंग टू गेट दिस एज 1. ठीक है, माइनस एक्स की जगह इफ यू पुट 0.5, so this will become 0.6, right? तो what do we get over here? तो बेसिकली रो अपॉन 0.8. अब ये रेशियो ले लेते हैं अपन. ठीक है, तो आर जो R1/R2 की जो वैल्यू है, वो बैलेंस्ड व्हीटस्टोन ब्रिज के कॉन्सेप्ट से क्या हो जाएगा, RAJ. ठीक है, डिवाइड बाई RJB. ठीक है, R1 की वैल्यू x है और R2 की वैल्यू 1 है. दैट मीन्स x विल बिकम RAJ/RJB. तो RAJ/RJB में माइनस रो बाई 8, ये 0.8 पाई कैंसिल हो जाएगा. तो दिस विल बिकम 1 अपॉन 0.6 माइनस 1 अपॉन 0.2 को 5 बोल सकते हैं. ठीक है, डिवाइड बाई 1 माइनस 1 अपॉन 0.6. करेक्ट. तो ऊपर से 0.6 एलसीएम आ जाएगा, सो यू आर गोइंग टू गेट -2 ऊपर. ठीक है, और फिर यहाँ पे 0.6 माइनस 1, तो यहाँ पे आ जाएगा -0.4. That means 2 by 0.4, which is 5. Hence, x comes out to be 5 ohms. So I hope guys you would have understood a fairly simple question. ये वाला रिजल्ट वैसे मतलब जो ये जो रेजिस्टेंस है ना इस वायर का, ये बहुत बच्चों को क्लास में टीचर्स कराते भी हैं, ऐसे फ्रस्ट्रम का जो रेजिस्टेंस होता है. ठीक है, ये बहुत ही स्टैंडर्ड फेमस क्वेश्चन है कि ऐसे R1 से रेडियस R2 तक जा रहा है, तो हाउ टू फाइंड द रेजिस्टेंस ऑफ दिस. तो बेसिकली बहुत ही स्टैंडर्ड सा क्वेश्चन होता है. ठीक है, तो आई होप यू वुड हैव अंडरस्टूड. थैंक यू.